Hello friends, welcome back. Hearty welcome to you. In this session, let's take some more simple examples and try to find out the domain and range of these functions. So the first function we have is 2x minus 3 by 5x minus 7. First we'll write about the domain. What we can say about the domain of this function? We know that this function is defined for all the values of x other than when the denominator is equal to 0. So can I say that 5x minus 7 should not be equal to 0. If 5x minus 7 equal to 0, then the function is not defined because in the denominator I'll have value 0. If 5x minus 7 not equal to 0, can I say 5x not equal to 7 or x not equal to 7 by 5 or 1.4. So the domain is given by all the values of real numbers or r minus of 7 by 5. That's the domain. Now let's go to the range. How to find out the range of this function? To find out the range, what we will do? As we did earlier, we'll try to say that y equal to 2x minus 3 divided by 5x minus 7. Now to find out the range of this function, the logic what we applied earlier and what we are doing now is we go to its inverse function and find out what is its domain. So I can cross multiply here and I can say y into 5x minus 7 is equal to 2x minus 3, or can I write 5xy minus 7y equal to 2x minus 3, or can I write 5xy minus 2x equal to 7y minus 3, or can I take x common and say 5x into 5y minus 2 is equal to 7y minus 3. So we just did cross multiplication. 5xy minus 7y equal to 2x minus 3. We try to get all x terms at one place so that I can write down x equal to 5y minus 2 by 7y minus 3. So now what is x value from here? X value is nothing but equal to, we'll write down here, we'll erase afterwards, x equal to 7y minus 3 divided by 5y minus 2. So the inverse function domain, the inverse function will look like y equal to 7x minus 3 divided by 5x minus 2. So now you know that for this particular function, the domain values, if you are able to find out, that is the range of our function. So what values are not allowed in the inverse function where 5x is not equal to 2, or can I say x not equal to 2 by 5. So the range, range will be all the values other than 2 by 5. We'll repeat again. We have been given 2x minus 3 by 5x minus 7. We have to find out the domain and range. We know that the function is defined whenever the denominator is not equal to 0. So 5x is not equal to 0, x is not equal to 7 by 5. So the domain is given by all real values minus 7 by 5. Now going to the range, we want to find out the range of this function. So the logic or approach we follow is we go to its inverse function and find out what values we can give to the domain. If we know the domain of inverse function, that's nothing but equal to range of the original function. Now y equal to 2x minus 3 by 5x minus 7. You just cross multiply them. You get 5xy minus 7y equal to 2x minus 3. Try to get the x value by taking all x terms to one side. I will have 5xy minus 2x equal to 7y minus 3, or x equal to 7y minus 3 divided by 5y minus 2. So now if you go to the inverse function, the inverse function will be y equal to 7x minus 2 by 7x minus 3 by 5x minus 2. Now in this inverse function, the domain is all the values of r other than 2 by 5, because at 2 by 5 the denominator will become 0. So this domain of the inverse function is nothing but equal to range of the original function. So range is given by all values other than 2 by 5. So that's how we can do the first problem. Now let's go to the second problem. Second problem is we have to find out the domain and range of square root of x minus 2 divided by 3 minus x. Now we know that any value, any function or any f of x which is there in the square root should be greater than or equal to 0, because if it is greater than or equal to 0, because if it is less than 0 we don't know square root of negative numbers. Those are not real numbers, those are complex numbers, which we'll learn afterwards. So can I say now x minus 2 by 3 by x 3 minus x should be greater than or equal to 0. So to understand what will be the values of x to satisfy this, what I will do, I will take the number line and I will say minus infinity here, infinity here, x minus 2. What are the critical points here? X minus 2 equal to 0, x equal to 3 minus x equal to 0, x equal to 3. Now since we know the values, let's go back now, try to understand which interval of these real numbers will hold this particular equation true. Suppose I put always the easiest way is put x equal to 0. If I put x equal to 0, I get minus 2 divided by 3 greater than or equal to 0, which is wrong. Which is wrong means where 0 comes between minus infinity to 2. So this interval is false. We don't need it. This interval is true, obviously. The next one will be false. This is always like once you know one interval, remaining can be easily told because they always switch. First is negative, then next is positive, next is negative. So this function is hold good only by the values in the interval 2, 3. So the domain will be 2 value can be included because 2 minus 2 is 0 allowed, but 3 is not allowed. That's why 3 is not included. So that's a domain of this particular function. Now coming to the range, we already said that anything inside square root should be greater than or equal to 0. That means the square root of that, whatever the range we want, also should be greater than or equal to 0. So the range is pretty simple. You can directly write down 0, infinity. So that's how we can do the second problem. So only interesting thing or important is we have to understand how to put the number line there and divide that into parts and understand that always check for that interval where you have 0, because it's very easy to substitute, and once you know it is true or false, you can take the remaining ones automatically, very easy. Now let's go to the third problem. Now we have to find out the domain and range of mod of x minus 1. We have to find out the domain and range of mod of x minus 1. So first we'll understand what is the domain. We have to find out. So I'll write down, we have to find out what is domain, and we also have to find out what is range of this particular function. So for that we will understand what actually this function is. How can I write it for different values of x? If I say y is equal to mod of x minus 1, then I know that y is equal to x minus 1 if x is greater than or equal to 1, and I also know that y equal to minus of x minus 1 when x is less than 1. We can check that if you want. Let us take a value of x equal to 2. 2 minus 1 mod of 1 is 1. So that's when it is greater than or equal to 1. When it is equal to 1, 1 minus 1 is 0. So the function is 0. When the values are less than 1, what happens if it is 0? 0 minus 1 is minus 1. Mod of that will make it 1. Nothing but minus of x minus 1. Suppose I take 0. 0 minus 1 is minus 1. Minus of minus 1. So this is called redefining the function. Whatever the function we have given, we are just trying to give its definition again. Now from here you can see that domain you can give all the values. There is no constraint from x side so that you cannot give a value of x. So I can say domain is all real numbers R. Whereas going to the range, we know that if x is greater than or equal to, you know that the modulus function itself is always make sure that the value is positive. So if x is greater than or equal to 0, y is always x minus 1. That means it is always positive. It is 0 or positive. 0 or positive. Now let's go to the other side. If x is less than 1, if x is less than 1, let us take 4 values. Suppose minus 4. Minus 4 minus 1 is minus 5. Minus of minus 5 is always 5. So x less than 1 also we are getting y equal to positive values. So what will be the range now? The range will be nothing but equal to 0 to infinity. So the domain is given by R and the range is given by 0 to infinity. These are some simple examples I just thought of sharing with you. We'll do more problems on functions as part of what we are dealing with, how to find out the domain and range of functions. So thanks for your time and support. I'll catch you once again. Bye for now.